some rational expressions. Here's a sum of two rational expressions. Notice that the denominators are the same. That means you can just go ahead and add the numerators. These two numerators, however, are not like terms, so you write them as a sum and keep the denominator the same. If the numerator and denominator have some common factor, then you can reduce, but these don't, so we're done. And that's the answer. Here's some more rational expressions. Think of the denominators as products of factors. The factors of the first one are a times b. The second one just has a. So let's ask ourselves, what would you multiply by to make them the same? You'd multiply by b. So multiply by b over b, which is equal to 1. That turns into 6 over ab plus 8b over ab. Now add the numerators. They're not like terms, so we just write them as a sum. And in the denominator, we have ab. We can only reduce if one of the factors of the denominator is a factor of every term in the numerator. And since 6 doesn't have a b, we can't factor out a b. We're done. Let's try this one. In this case, we want to look at the prime factorizations. So this is 2 times 3 times v, and this is 2 squared v. We need both expressions to have the same prime factorization of the denominator, and the new denominator has to include all the prime factors of both of these. In other words, we've got to have a 2, a 3, and a v, and we have to have 2 squared and v. But we don't have to duplicate any of those. So since they both have v, we don't need to worry about that. And they both have 2, but the one on the right has an extra 2, so we do need to multiply by 2 over 2 in the first fraction. And the second one doesn't have 3, so we need to multiply by 3 over 3 in the second fraction. Now the two prime factorizations are the same, so we can go ahead and finish the problem. It turns into 10 over 12v plus 21 over 12v. Now we can add our numerators. Since these are like terms, we can add them together. Now, can we reduce? Well, 31 is a prime number, so we can't take any factors out of the top and bottom. We are done. All right, let's look at the prime factors of these two fractions. On the left, we've got 2 squared, y squared, and on the right, we've got 3 times 5 times x. Do you see any common factors? None. When there are no common factors at all, you simply have to multiply the two denominators by each other in order to get a common denominator. So let's multiply this fraction by 15x over 15x. And let's multiply this fraction by 4y squared over 4y squared. Let's simplify. We get 45x squared over 60xy squared. And this is a subtraction problem. On the right, we've got 4y to the third over 60xy squared. Now don't assume that that second one turns out the same. Really do the math here, because that's a good way to check your work so far and see if they really come out the same. Now, in our final answer, we want to go ahead and do that subtraction, but these are not like terms, so we're not going to be able to actually combine them. We're just going to write it as the difference of 45x squared minus 4y to the third. The denominator is now 60xy squared. You want to take a moment to look at the top and see if you can factor out any common factors. 45 is made of 3 times 3 times 5, and 4 is made of 2 times 2, so there's no common factors here. We're done. And here's a special challenge that's going to lead to a trick you want to remember for the next 4 to 10 years, let's say. These two denominators are not the same, so let's explore that. We've got y minus 8 versus 8 minus y. I'm going to rewrite that in the same order. So put the negative y first plus 8. That's an equivalent expression to 8 minus y, right? Now look at these two and ask yourself, is there anything that I could multiply here to change it into this? And there is. You could multiply this by negative 1. That would make negative y plus 8, right? Because really, these two terms are both opposites of these two terms. So if you multiply it by -1, they'll both change to their opposites. So the factor that we needed is -1. And that might not be obvious in the original problem. But whenever you see expressions like this, for example, 2 minus x, x minus 2, or z minus 5 and 5 minus z, do you see what I'm saying? These are always different by a factor of -1. All right, let's finish the problem. So we need this to happen in the left expression. So I'm going to multiply by -1 over -1. That gives me -7x over -y plus 8 minus 6x over -y plus 8. And that equals, if you think of it as add the opposite, that's -13x over -y plus 8. In our final answer, it is best to rewrite that binomial with the fewest number of symbols possible. So I'm going to mix that order back up again. I'm going to leave the -13x up here and rewrite the denominator as 8 minus y, saving myself one math symbol there. And that's our final answer because it cannot be reduced. So that's an important trick that's going to come up many, many times in your mathematical future. And that is all you need to know for now, but I do have something for you to think about. We're going to get to this later in the year. If you want to play with it now, just remember to think of these as products of factors and see what you can do. Okay? That's it for now. Good luck on your homework.